So now we want to go and do the section 9.1 additional exercises. So we want to determine if the relation defines y as a one-to-one function of x. So it needs to be a function and it needs to be one-to-one. So first thing I'm going to do is I'm going to check the x values. My x values are all distinct, so that means it is a function. And then we'll check the y values. They're all distinct as well. So this would be yes. It defines y as a one-to-one function. All right, let's look at 1b. And remember, we have to first check it's a function. And so notice in b, even though you might say, hey, all the y values are different, we're in trouble with the x values. This is not even a function. So this is not a function. So it's certainly not a one-to-one function. All right, so let's try the next one. Denver, Philadelphia, Utah, and Orlando. Okay, those are all different cities. Nuggets, 76ers, Jazz, Magic look like they're a professional basketball team. So each X is different, each Y is different, so this is one-to-one. My dyslexia kicking in. Sorry about that. All right, let's try this next one. And even though it is a function, I got the same y value coming from two different x values. So this is not one-to-one. All right, let's move on to number 3. And if you look at this, each horizontal line passes through at most one point. So yes, it defines y as a one-to-one function. Whereas if I look at number 4, well, I can take a horizontal line right here. I hit more than one point. I can also take one down here too. So this is not one-to-one. Let's try number 5. Given that the domain of a one-to-one function f is -2, including -2 to 3, and the range is -1 to infinity, state the domain and range of the inverse function. So remember, domain and range, we switch them around. So this is going to be the range of F inverse. Whereas this is going to be the domain of F inverse. See if I can write that a little bit better. All right, so I'm looking for a domain of this. Well, that eliminates A, and that eliminates B. All right, now I'm looking for this range, so it looks like it's going to be C. Keep in mind, when I'm writing this here, I'm not switching the x and y coordinates, because these are not coordinates, these are intervals. I'm switching the domain and range. That switch has already happened. So don't try to switch this to -3, 2. You're not switching the x and y values because these are not x and y values. This is interval notation. Let's take a look at the next problem. So the graph of the function is given, graph the inverse, and they actually give us some choices. So what we want to do here is follow some points. So my first point here is -3, comma -1. So if I switch the x and y coordinates, and now here I do switch these values because these are not intervals, these are points. That gives me -1, 3. So it could be that one. It's not that one. Let's check these others. Not that one. And not that one. So actually it's going to be A here. So we're going to circle A. We can verify because if I switch this, -1, 0 becomes 0, -1. 2, 3 becomes 3, 2. Just kind of matching these other ones up here real quickly. So again, it's kind of a process of elimination when you're doing this, because when I switch that, that becomes 1, 0. And when I switch this one, that becomes 3, 2. So A is the match. All right, so again, I'm going to pick some test points. So maybe I'll take this point here at 0, 1. So I'm looking for the ones that have 1, 0. So A does, B does not, C does not, and D does not. So we think it's A. Nope, that's my bad. My bad on that one. 1, 0, that does not go through, so let's do this again. My bad, I'm doing it too quickly. So let's start over. So this is 0, 1. If I switch the x and y coordinates, I should get 1, 0. So I look for graphs that have 1, 0. So an x-intercept. So that does not, so I'm going to eliminate A. B works, and so does C. D does not work. So it's either C or D, or B or C. So now I'm going to pick a different point. Maybe I'll pick this point up here. 1, 4. I'm going to switch the x, y coordinates. That should be 4, 1. Okay, B has the point 4, 1. C does not. So now we can eliminate C. That means our answer choice is B. So I'm just picking points, switching the x and y coordinates, and then testing which graph has those and eliminating the ones that do not have those points until I get down to one answer choice. Let's try number 8. It says graph f of x equals 1/3 x minus 2 and f inverse. Well, this one we know how to graph. This has a y-intercept of -2. My slope here is 1/3. So I'm going to go up 1 over 3. So I'm going to plot that y-intercept -2. I'm going to go up 1 over 3. And let's just again go on 1 over 3. And I didn't bring a ruler with me. Let me see if I can use this edge here to get us a line. So that's our f. Now to graph f inverse, well, I'm going to switch the x and y coordinates. So let's do that in blue. So 0, -2 becomes -2, 0. 3, -1 becomes -1, 3. 6, 0 becomes 0, 6. Let's see if we can draw that. I'm going to pretend that's a straight line. Okay. So this would be my f inverse. Okay, so now, so that's part A. We graph these. Part B says write the equation for f inverse. Well, I have a y-intercept of 6. My slope here, well, I can tell here, I go up 3 over 1. That would be 3, so it should be 3x plus 6. Now, C says find, and let me get the colors right here, f composed f inverse of -4. So now we're working on part C here. So remember our composition, this is f of f inverse of -4. So I'm looking at -4, looking at my graph, and that is way down here. Excuse me on that. So I'm going to go to my scratch paper, so I'm going to put it up here. Let's find f of f inverse of -4. I'm not going to easily read off that graph, so let me just do it algebraically because we know what the equation is. So it's 3 times -4 plus 6. So that would be -12 plus 6 equals -6. So you see I didn't quite get the graph drawn correctly here, and a little hard to. So but if we do it algebraically, it's -6. So now we're taking f of -6 and guessing that's going to be -4, but let's do it algebraically. So I'm going to take 1/3 -6 minus 2. That's a -2. Minus 2 is a -4. Now remember what inverse functions are. An inverse function undoes what the original function does. It does the reverse operations in reverse order. So if I'm doing -4, if I take this composition, I should get back where I started. Same thing should happen here when I do this one. Let's try it. So we're going to do, this time my f inverse is going to be on the outside. And let me go to my scratch paper and do f of 9. So looking at f of 9, plugging it here. 1/3 of 9 is 3. 3 minus 2 is 1. So doing f inverse of 1, I plug in 1. Again, I'll go back, I'll do it algebraically just to make sure. So I'm going to use this 3x plus 6. And that gives us 9. So notice again, composing a function with its inverse, I get the same thing I started. So for part D, you can guess if I do f composed f inverse of x or f inverse composed f of x, in both cases I'm going to get x. That's what should happen when you compose a function with its inverse. Let's try another one. So here I graph the cube root of x plus 2 minus 1. So here I've got my cube root function. And remember what that looks like. Get some points here to follow. This has been shifted left 2, down 1. Okay, so 0, 0, I go left 2, down 1, that ends up here. 1, 1, shift left 2, down 1. -1, -1, left 2, down 1. And we're going to start sketching this in here. So it's going to look something like that. So now I'm going to find f inverse. So this is my f. And we're going to do it by switching some x and y coordinates. So this first one, -2 comma -1 becomes -1, -2. So that's down here. -1, 0 becomes 0, -1. It's here. This point here, -3 comma 2 becomes -2 comma 3. And instead of curving down, this is going to be curving up. Went too steep there. There we go. So notice what this function is. This is my x cubed function that's been shifted 1 to the left, 2 down. All right, so we've already done part A here. Part B, this is my x cubed function. It's been shifted 1 to the left and down 2. Now, can you guess what's going to happen when we do the composition? We should get -2. Let's see if we can do it on the graph first. So I'm going to put C here. We got f is our outside function. F inverse is our inside function. And I'm doing this of -2. So let's see if we can do it on the graph here. If I look at -2 on my graph, I should get -3 as an answer. And I'll let you on your own verify that algebraically. And then I look at f of -3, I should get -2 for an answer. So again, notice I'm getting the same thing that I started with. All right, let's see if we can do C on the graph. So this time, my inverse function is on the outside. So we'll do the second part of C on our graph. So this would be f inverse of f of 6. F of 6 looks like it's about 1. Now, if you're not sure, verify it. 6 plus 2 is 8. Cube root of 8 is 2. 2 minus 1 is 1. And now if I do f inverse of 1, that looks like to be about 6. Now again, I can verify it. If I plug in 1, 1 plus 1 is 2. 2 cubed is 8. 8 minus 2 is 6. So again, notice I'm getting the same thing back that I started with when I composed the inverse. So you can guess what part D is going to be equal to. That's going to be equal to x, and that's going to be equal to x. That's done.